Have you ever wondered how mountains are formed? Why these towering blocks of rock have risen above the rest of the landscape? That's one of the reasons why I became a geologist, to find out and understand and tell the story of mountains. This is my field area, the Old Woman Mountains in the Mojave Desert of California. And a brief synopsis of their story is that they're composed of granite, solidified masses of molten rock that form deep in the Earth's crust by melting of other rocks. And over time, epic processes of tectonic uplift and erosion have exposed them at the surface where I can go and chip at them with my geological hammer. From the samples that I collect, I can obtain geochemical information that add detail about the life of the granite. What were the parent rocks to the granite? When was the granite born? How did the granite change over the course of its life? And the way in which I do this is to examine zircon grains. Now, zircon is a tiny mineral, about the 1/10 of a millimeter in size, and it forms in granites, and it acts like a diary. It records everything that happens throughout a granite's life. These are images of individual zircon grains generated by bombarding them with electrons and causing them to luminesce. And they luminesce different colors based on their chemical composition. And as you can see, the composition isn't uniform throughout the grain. It's what we call zoned. And each of these zones represents a discrete geochemical moment in time, a chapter in the granite's life. And the way in which we read these chapters is the first chapter's in the middle, and we read outwards as the grain grows. And the way that we read them is we shoot them with a laser, and then we analyze the ablated material in mass spectrometer. I basically interrogate them to find out their geochemical secrets. The good thing about zircon is that it contains uranium. And so when the zircon forms, the uranium radioactively decays into lead isotopes. So if I measure the ratios of the uranium to the lead, I can find out time-related information. So analysis of the cores, the first few chapters of the zircon, revealed that they're initially 2,000 million years old. That's about half the age of the Earth. A couple of chapters later on, we read about ancient mountain building events that are linked to the growth of the North American continent at about 1,700 million years ago. Then we've got grains like this one that are 72 million years old. At that time, dinosaurs were roaming the surface, but at 20 kilometers below, there was a large magma chamber full of molten rock that these zircons fell into. And this is what eventually solidified to form the rocks of the Old Woman Mountains. Now, this is just one geochemical question that I can ask of zircon. I can ask different questions and get different information. After I've interrogated my 300 zircons from my 11 samples throughout 400 square kilometers of these mountains, it's my job to piece the individual stories together to create the biography of the Old Woman Mountains. Thank you very much.